Bedlam is a large-scale synthetic video dataset designed primarily to train and test algorithms on the task of 3D human pose and shape estimation. It contains diverse body shapes, skin tones, clothing, and motions. Beyond previous datasets, Bedlam has simple X bodies with hair and realistic clothing that is animated with cloth simulation. We render varying numbers of people in realistic scenes with varied lighting and camera motions. Achieving such sufficient realism and scale is non-trivial. We use Bedlam to train and evaluate different networks for human pose and shape estimation. We find for the first time that training on synthetic data alone is sufficient to achieve state-of-the-art accuracy on natural image datasets.
Hello, I'm glad to introduce our new work, Matching Primitives, Shapes Abstraction from Signed Distance Function. Representing complex objects with basic geometric primitives has long been a topic in computer vision. Primitive-based representations have the merits of compactness and computational efficiency in higher-level tasks such as physics simulation, collision checking, and robotic manipulation. Unlike previous work which extract meshes from a signed distance function, we present a novel method named matching primitives to obtain a primitive-based abstraction directly from an SDF. In this paper, we focus on a versatile geometric primitive called supercogix to represent scenes. A supercogix with a general pose is only encoded by 11 parameters. More importantly, supercogix have closed-form Minkowski sum, making it an efficient representation for collision detection and motion planning.
In object pose estimation, we are given a 2D image depicting depicting an object and also the 3D CAD model of this object. Our goal is to detect the object in this 2D image and also to estimate its 3D rotation and translation with respect to the camera. In object pose estimation, the famous two-stage pipeline works as follows. In the first stage, we train a neural network to detect 2D semantic key points in this image, such as shown here. In practice, this neural network can often make mistakes and generate a set of wrong matches that we call outliers. And then in the second stage, given these correspondences, our goal is to estimate the 3D rotation and translation. A well-known heuristic algorithm in this stage is called RANSAC, which stands for Random Sampling Consensus. So what can possibly go wrong with this two-stage pipeline? We argue that there are three challenges associated with this pipeline. The first challenge is that RANSAC and similar algorithms can fail without giving any notice. The second,
we propose neural part priors, which are learned parametric object part priors encoded into latent spaces that can be optimized over at inference time, fitting precisely to objects in real-world scan scenes and enabling accurate, holistic scene reconstruction. Our aim is to parse real-world scene observations into their part decompositions via test-time optimization over a parametric part space, enabling accurate geometric representation of input observations and ensuring part consistency between similar objects detected in a scene. Current methods make independent predictions per object, with a single forward pass on each detected object. This produces both inconsistent predictions in a scene, as well as results that do not precisely match the input geometric observations. Our approach takes as input an RGBD scan. We first estimate independent predictions for part decompositions of each detected object. We then refine the estimates by optimizing over our parametric latent space to fit both input geometry constraints, as well as We present panoptic lifting for 3D scene understanding with neural fields. With the availability of large-scale labeled 2D data and advances in model architectures, state-of-the-art 2D panoptic segmentation methods perform well, even for images in the wild. However, when applied on multiple views from a scene, they can exhibit issues like inconsistencies in predictions across views. Furthermore, the instance labels are not valid across views. Our method, panoptic lifting, tackles this problem by directly lifting 2D machine-generated labels to a 3D representation. Given only RGB images of a scene, we first pre-process the images to obtain poses and machine-generated 2D segmentations using an off-the-shelf model. We then optimize a volumetric neural scene representation that can be queried for the color, density, semantic, and instance labels for each point in space.
Hi everyone, my name is Yiming Li, and I'm a PhD student from NYU. Today I'm very happy to present our CVPR highlight paper, VoxFormer, Sparse Voxel Transformer for Camera-Based 3D Semantic Scene Completion. This is a joint work with Zhiding, Chris, Chawei, Jose, Sanya, Chen, and Anima. Firstly, let's do a quick overview of our paper. Our target problem is how to lift RGB images into a complete 3D semantic volume. To solve this problem, our basic intuitions lies in two folds. The first one is how to leverage sparsity in 3D, since there are a lot of empty spaces in 3D space. And the second one is reconstruction before hallucination will provide better featurizations to learn complete 3D representation. And to leverage these two intuitions, we design a novel two-stage transformer-based architecture to achieve both efficient and effective 3D semantic scene completion.
Welcome to this presentation video for the paper titled Renderable Neural Radiance Map for Visual Navigation. Our paper presents the Renderable Neural Radiance Map, or RNL map, designed for robot navigation. Assuming a robot equipped with an RGBD camera and wheel odometry information, it can record the visual information from the environment into RNL map. The visual information in its grid cell enables many useful features which is useful for navigation. We also want to highlight the main characteristic of RNL map, which is visually descriptive, generalizable for arbitrary scene, and real-time capable. Let's begin with the motivation behind our work. Imagine a robot agent navigating a 3D environment. Here, how can we embed the visual information from a 3D environment into a 2D form? And more important,
Hi everyone, I'm Benjin Zhu. I'm glad to be here to present our highlight paper, Courier Contrast Voxel DETR for 3D Object Detection, or CONQUER. DETRs have revolutionized object detection with its transformer architecture and one-to-one matching, but its set matching laws only supervise each query individually without considering inter-query relations. Moreover, its fixed top-K outputting scheme causes duplication in the final detections. To tackle this problem, we propose query contrast, which explicitly enhances each GT's master query and suppress predictions of all other unmastered queries during training. Specifically, we encode both queries and GTs into a unified latent space by the transformer decoder layers. In this space, we construct positive and negative GT query pairs based on the Hungarian matching results and conduct contrastive training to achieve our goal.
In this work, we consider the problem of learning sample estimation on 4D radar point clouds using cross-model supervision. Our motivation is based on the fact that self-driving cars today are equipped with multiple heterogeneous sensors, and we argue that such collocated perception redundancy can be used to provide supervision cues for radar sample learning. We propose a cross-model supervised learning pipeline for 4D radar sample estimation. A multitask model architecture is introduced for the identified problem. We retrieve various supervision cues from 3 collocated sensors and train the model end-to-end using cross-model constraints. We demonstrate the state-of-the-art performance of our method and show its effectiveness in downstream tasks as well. Here are some demos showing our.
We present Motion Diffuser, a learned representation for controllable multi-agent motion prediction using denoising diffusion models. Our model sequentially evolves a set of random samples into a diverse and multimodal joint distribution over future outcomes. Motion Diffuser learns a distribution over agent trajectories that is diverse, simple, requiring a single L2 loss, and permutation invariant over multiple agents. Motion Diffuser enables sampling under constraints, such as enforcing rules and physical priors, or creating tailored simulation scenarios. Motion Diffuser also enables computation of the exact log probabilities per trajectory. Finally, we achieve state-of-the-art results for multi-agent motion prediction. We briefly present an overview of the model architecture as follows. Scene inputs such as agent history, context agents, traffic lights, and road graph are first encoded using a powerful
In this paper, we introduced the first framework to learn human-to-robot handovers from vision input. Teaching robots to solve this task is challenging, because the robot needs to react to complex and dynamic human behaviors. Therefore, training human-to-robot handovers requires an accurate simulation of human behavior. Recent work has introduced a simulation environment for benchmarking human-to-robot handovers. However, this environment has only been used for evaluation purposes and not for policy learning. We leverage this environment to train handover policies. We introduce a two-stage teacher-student training procedure that can be used to train policies with a moving human in the loop. We demonstrate that our method generalizes to unseen motions. We show that our approach transfers to a different physics engine. We evaluated our method on a real system and found that it performs better than the baseline.
Hello everyone, we present our work OpenGate revisiting gate recognition toward better practicality. And this slide is produced by Chao Fan, and I am Chuan Fuzhen, offering this speech. Gate recognition is one of the most critical long-distance identification technology, and it has gained increasing attention in both research and industrial communities. We find that existing methods perform poorly in the wild, and some conclusions drawn from the indoor dataset cannot be generalized to the real application. Therefore, the primary goal of this paper is to present a comprehensive benchmark study. To this end, we first developed a flexible codebase named OpenGate, and we revisit the recent state-of-the-art method, and we develop a simple, powerful, and robust baseline model named GateBase.
We present MoFusion, a new framework for conditional 3D human motion synthesis based on denoising diffusion models, or DMM. Our motion synthesis framework can be conditioned on several input modalities, such as music or text. For example, let's consider these dance motions. These dance motions have been synthesized by the proposed MoFusion framework with music as the conditioning input. Similarly, MoFusion can also be trained to synthesize human motion based on text prompts like these.
Hi, my name is Sangjil Lee, and I will talk about our paper exploring discontinuity for video frame interpolation. Here's a summary about our paper. Previous studies have been conducted on natural videos containing only continuous motions. However, many practical videos contain various unnatural objects with discontinuous motion, such as logos, user interface, or subtitles. Therefore, we propose three techniques that can make the existing deep learning-based VFR architectures robust to this element. First is a novel data augmentation strategy called figure text smithing, which can make the models learn discontinuous motion during training stage with.
In this video, we will introduce our work B-spline texture coefficients estimator for screen content images per resolution. Let's start with a short preview. In this paper, we propose a B-spline texture coefficients estimator called as BTC, which is a screen content image per resolution method. To reconstruct high-resolution image on arbitrary magnification, our BTC represents the high-resolution image on continuous manner with implicit neural function. Here, BTC estimates the B-spline features from input image, and the followed implicit neural function utilizes the B-splines to recover high-resolution image. Thanks to the B-spline representation, BTC preserves discontinuities well without under-overshooting aliasing. As a result, our method outperforms other single image per resolution methods.
Hello, I'm Mingguk Kang. I will present our work on scaling up GANs for text-to-image synthesis. Text-to-image has recently become quite popular. For example, large-scale diffusion models are able to synthesize realistic image given a text prompt. In this study, we aim to achieve the same capability with a GAN model and present GigaGAN, the first 1 billion parameter GAN for fast and high-quality text-to-image synthesis. Here we show that our FID is comparative with diffusion and autoregressive models, while being much faster without iterative sampling step for inference. GigaGAN generate a 512 pixel image in just 0.13 seconds. Particularly, GigaGAN show high resolution image upsampling at an unprecedentedly fast speed. For instance, GigaGAN require only 0.13 seconds for 1K upsampling. This concludes the 1-minute summary.
We present ERNIE VILG 2.0, an enhanced text-to-image diffusion model that leverages knowledge-enhanced mixture of denoising experts to improve the quality of generated images. Denoising diffusion probabilistic models are score-based generative models that have been successful in text-to-image generation. DDPM utilizes a diffusion process where Gaussian noise is iteratively added to an initial data sample, gradually transforming it into an isotropic Gaussian distribution. The denoising process aims to reverse this diffusion and restore the original data distribution. During training, the model predicts the noise added at each diffusion step, and a denoising network learns to restore the initial data sample by minimizing the difference between the predicted and actual noise.
Hi everyone, we are from National Yang Ming Chiao Tung University, Taiwan. Today, we present our work in video coding titled Hierarchical B-frame video coding using two-layer GAN without motion coding. Our proposed direction for Deep VC involves a two-layer system without motion coding we call TLCMC, which differs from typical Deep VC systems that use hybrid system with motion coding. We have two layers. The base layer, where we perform motion prediction, downsample and low-scale interframe compressions and super resolutions, and also the enhancement layer, with merging operations and original scale interframe compression. Our TLCMC components are modular and can be enhanced. Our RT curve demonstrates that the LCMC variants can compete with the state-of-the-art PCAN result in certain video scenes. Our designs offer less computational complexity on the encoder and decoder side compared to PCAN. In summary, we demonstrate the first attempt at DVC that has less computational complexity and can perform well even without motion coding.
Hi, this video is for the introduction of our paper towards high quality and efficient video super resolution via spatial temporal data overfitting. Leveraging the overfitting ability of the DNN to achieve video resolution upscaling has become a new trend in the modern video delivery system. However, a large number of chunks are expected to ensure good overfitting quality, which substantially increases the storage and consumes more bandwidth resources for data transmission. To solve this, we propose a novel method for the high quality and efficient video resolution upscaling text, which leverages the spatial temporal information to accurately divide video into chunks. Thus,
Hello everyone, I presented my work on INR, a novel regularizer that improves the generalization ability of INR. INR uses Dirichlet energy to measure similarities between rows columns of the matrix, integrating the smoothness of the Laplacian matrix. INR represents various signals by mapping coordinates to signal values, as shown in the top row of slides. INR can be used to represent sound, images, 3D scenes, and objects. However, the initial use of ReLU as the activation function did not represent high-frequency signals well. Therefore, in NeurIPS 2020, researchers proposed using Fourier features to map input coordinates to obtain better representation performance for high-frequency signals. Similarly, the work Siren, also published in NeurIPS 2020, directly replaced the ReLU activation function with the sine function and achieved better results than simply.
We introduce the Masked Generative Video Transformer, or MAGVIT, to tackle various video synthesis tasks with a single model. MAGVIT performs favorably against state-of-the-art approaches and establishes the best published FVD on 3 video generation benchmarks. For example, on the challenging Kinetics 600 dataset, MAGVIT yields a 39% improvement over the previous best result. A single MAGVIT model can accommodate multiple generation tasks, such as frame prediction, frame interpolation, video outpainting, video inpainting, class conditional video generation. MAGVIT is trained in 2 stages. In the first stage, we learn a VQ autoencoder to quantize a video into discrete tokens in both spatial and temporal dimensions. In the second stage, we learn a transformer by
Hi everyone. I will introduce my paper Cap4 video. What can auxiliary captions do for text video retrieval? This work is selected as a highlight paper at CVPR 2023. In this paper, we explore a novel problem: leveraging auxiliary captions to further enhance existing text video retrieval. We leverage the knowledge of large-scale vision language models, such as CLIP, and large language models, such as GPT-2, to generate diverse captions for arbitrary videos. When provided with auxiliary captions, a natural question naturally arises: how can we leverage these captions to enhance the text video retrieval task? We propose the Cap4 video, which maximizes the utility of the auxiliary captions through 3 aspects. 1. Input data augmentation for training. 2. Intermediate video caption feature interaction for compact video representations. And 3. Output score fusion.
Compositionality is an important characteristic of human intelligence. It enables people to reason about new and complex language and visual scenes by composing their understanding of individual parts. However, can our best vision language foundation models reason compositionally? To answer this, we introduced CRIP, a benchmark that measures vision language models' compositionality in 2 aspects: systematicity, how well a model generalizes to unseen conversations, and productivity, how well a model comprehends increasingly complex expressions. We generate large-scale datasets of image caption pairs and high negative captions for image-to-text retrieval evaluation. We evaluate vision language models across 7 architectures trained with 4 algorithms on massive dataset. And our results suggest that this model do not exhibit systematicity or productivity, and neither emerges as we scale up the training dataset or model size.
Hi everyone, I'm glad to introduce our work in CVPR, context-aware alignment and mutual masking for 3D language pre-training. To begin with, let me introduce a preview of our work. In this paper, we propose a 3D language pre-training approach that aims to establish fine-grained interactions between point clouds and their texture descriptions, thus learning universal multimodal features for various 3D vision language tasks. We first semantically align 3D language features and then further enhance their granularity using mutual masked learning. Our proposed 3D language pre-training method achieves promising results once adapted to various downstream tasks, including 3D visual grounding, 3D dense captioning, and 3D question answering.
Existing vision language models are designed for image-level tasks such as classification and retrieval. In this paper, we aim to enhance the image-text pre-training for region-level downstream task, which is open vocabulary detection. At pre-training, we propose to randomly crop and resize regions of positional embeddings instead of using the whole image positional embeddings. This better matches the use of positional embeddings at region level in the detection fine-tuning. In addition, we replace the common softmax cross-entropy loss in contrastive learning with focal loss to better learn the informative yet difficult examples. We achieve state-of-the-art on LV's open vocabulary detection, outperforming the best existing method by a large margin. Surprisingly, WED improves the image-level representation as well and achieved the state-of-the-art on image text
In the deep learning era, there are two main challenges of semantic segmentation models. First, during training, it requires costly pixel-wise annotations. In testing time, it cannot recognize unknown classes. To address these challenges, we are inspired by two lines of research. First, self-supervised methods can learn coherent pixel embeddings without pixel annotations. However, it still needs annotations for fine-tuning to make predictions. Also, it cannot handle unknown classes. On the other hand, language-driven models leverage pre-trained vision language models, such as CLIP, to make segmentations for arbitrarily given class names. However, it still needs a set of predefined class names during training time. We present CLIP S4, a language-guided self-supervised semantic segmentation method. Our method does not need pixel annotations during training or fine-tuning. We also do not need predefined class names, like mask CLIP plus. Finally, we can conduct arbitrary segmentation.
Hi, my name is Rohit, and I'm going to describe our work on Beyond MAP. We notice a lot of clutter in instance segmentation methods, especially a lot of false positives. A deeper dive into these false positives reveals that these are actually not penalized by the MAP metric, as you can see here. These predictions are what we call hedge predictions, and we propose methods to quantify the amount of spatial and categorical hedging. Taking inspiration from bottom-up methods, we propose a semantic NMS and a semantic sorting, and these are to remove the extra false positives without affecting MAP too much. Qualitatively, we see a lot of improvement in the COCO dataset, where you can see a number of these extra predictions are removed. And with this, we take a deeper dive into the material.
Hi everyone. We introduce Protocon for semi-supervised image classification. Protocon addresses label-scarce regimes when only a very small portion of the data is labeled. First, for each unlabeled image, we obtain a pseudo-label, which is the model's softmax probability. However, this is usually prone to overconfidence, which increases the chances of a confirmation bias. Hence, we jointly train a prototypical representation space where our images are all projected. Subsequently, we obtain a secondary pseudo-label based on the image's nearest neighbor in that space. Finally, we combine the two to obtain our final refined pseudo-label. This is used to train the network via a consistency regularization objective. Protocon employs online constraint clustering to identify the neighbors without needing to store image embeddings. This leads to a 16x reduction in memory requirements while achieving state-of-the-art performance.
Hello everyone, I'm glad to report our paper to today. This work is from the School of Artificial Intelligence here at University. This report is divided into the following 4 parts. I will first give a summary of this paper. This paper focuses on unsupervised model adaptation. Exciting UMA methods adopt offline self-training, but it requires expert iteration. Online self-training can avoid the drawback of OST and shows potential in unsupervised domain adaptation. From the figure below, OST methods suffer from stability and adaptability in UMA. So to apply OST to UMA, we explore 2 reasons for this and propose 2 methods for these reasons. Next, I will go into other details of the paper, starting with motivation for the research. UDA in semantic segmentation transferred knowledge.
In this study, we propose a framework for generalizable INRs via instance pattern composers. Our approach uses a coordinate-based MLP that is shared across multiple data instances, yet capable of representing individual data instances by modulating a small set of weight metrics. In specific, modulating only one weight matrix in the second MLP layer is sufficient to achieve high-performing generalizable INRs that can effectively represent data instances as a continuous function. Then, how the modulation weight can be predicted? Our framework is compatible with both hypernetwork and meta-learning-based approaches. For a more detailed explanation, please continue watching this video or refer to our published paper and implementation.
Suppose we want to train an online continual learning method on this stream of data. What most existing work assume is that the stream is as fast as the training method. However, let's consider a realistic scenario where the stream could be faster than the training method. In this case, we assume that it is twice as fast as the training method. In such case, the method would end up training on half of the stream, eventually skipping every other batch of data. We apply this concept on different algorithms from the online continual learning literature, and we show that AR, the simplest method, end up outperforming all considered methods.
Hi everyone, we are delighted to deliver the presentation of our work here, accelerating dataset generation via model augmentation. In this work, we propose to utilize model augmentation techniques to accelerate dataset generation. First, we briefly introduce the background of dataset generation. Dataset generation distills a large-scale dataset to a small and a synthetic dataset. As you can see in the below figure, we distill the original CIFAR-10 dataset, whose size is 50,000, to a synthetic dataset, whose size is only 10. The network trained on the small synthetic dataset is expected to match the network trained on the original dataset. With a small dataset, it takes far less time to train a network.
Hi everyone, I'm pleased to present our work, OpenMix, exploring outlier samples for misclassification detection. Here is an overview of our work. Deep neural networks tend to be overconfident for their wrong predictions. In this paper, we propose to leverage outlier data for misclassification detection. We provide analysis of why the well-known out-distribution detection methods are harmful for detecting misclassification errors. The proposed OpenMix, which includes learning with reject class and outlier transformation, is a unified method for both misclassification detection and out-distribution detection. Here is the background. Deep neural networks, especially vision models, have been widely deployed in safety-critical applications like autonomous driving.